algebra, we are starting CO14, which is simplifying expression when raising a power, product, or quotient to a power. Kind of the shortened version of this is called a power to a power. And if you notice, what do all three of these expressions have in common? I'm trying to help you look at things you can see to identify which rule you need to use. If you see those multiplication symbols, right, those dots, you know it's CO10. If you see a fraction, you know it's divided by the same base as 0 power, negative power. What do all of these three have in common? Yeah. All have parentheses, okay? And the reason why they all have parentheses is because, remember what parentheses do, right? They expand the base. Okay, without parentheses, and you don't have to write this down, but without parentheses, 3n squared, the only thing being squared is the n. With parentheses, you're also now squaring the 3, right? So what parentheses do is they include other stuff, usually coefficients or multiple bases, with the power that's on the outside. So just like we did before, we are going to explore this using expanded form. First of all, I guess the definition for distribute, we've defined this before with equations. What does it mean to distribute something? Yes?
To give out, like multiply.
To give out, to multiply, okay? In this case, it means to give the power to each coefficient or base, I need to add a second line for this, in the parentheses. Okay? To give the power to each coefficient or base in the parentheses. You're distributing the exponent into each coefficient to each base within the parentheses. Okay? So, for example, this first one, we look at what's inside of our parentheses. 3 is a coefficient, right? N is a base. We distribute this power to each of them. Oh, no, we're not doing this yet. No, that's the rule. We're doing this in expanded form. Sorry. Woo! In expanded form, what is 3n squared with the parentheses there? Nolan.
Oh. Wait, 3 times n?
That's what's inside the parentheses. In expanded form, what is this expression in expanded form? What's being squared and what does it look like?
The 2. 3. Wait, no, the 2. It's the 2.
Anthony?
Isn't it like 3 times n times 3?
Times n, right? If we're squaring 3n, 3n's the base, that means we're taking 3n times 3n, right? That's what's being squared. 3n times itself, okay? 3n times 3n. And if we simplify this, how many 3's do we have being multiplied together? 2. We can write that as 3 squared, right? Right? We can take this 3 here and this 3 here. 3 times 3 gives us 3 squared. Okay? How many n's do we have there?
2.
2. And how can we write n times n?
N squared.
N squared. Okay? So our simplified expression here becomes 3 squared n squared. 3 squared n squared. Because if we're squaring 3n, we have 2 3's, we have 2 n's, 3 squared, n squared. Okay? The next one. 10xy squared taken to the third power. Now, the base of this power of 3 here is the whole thing, right? Everything in the parentheses, which means that's what's being cubed. Everything in the parentheses. So we have 10xy squared times another 10xy squared times another 10xy squared. Right? If we're cubing what's inside the parentheses, and what's inside the parentheses is 10xy squared, we've got 3 of them. We're multiplying that base times itself. Are there questions on how I got that?
Okay, no, I get it.
Some of you are probably thinking, well, that doesn't look a whole lot simpler than what we have. Why are we even doing this? It just looks longer, okay? But what we're doing is we're getting rid of the parentheses, okay? The purpose of distributing something is to get rid of the parentheses. We saw that with equations also. 3n squared, when we distribute, when we use this rule, the parentheses are now gone. We have 3 squared times n squared. The same thing will happen here. How many 10s do we have all being multiplied? 3. How do we write 10 times 10 times 10? Using the power? 10 cubed. How many x's do we have all being multiplied together? 3. How do we write x times x times x?
X cubed.
X cubed.
And then y cubed.
How many y's do we have all being multiplied together?
3.
No.
5. 6.
6. Why 6?
Because y is being squared.
Because each one of these represents 2 of them, right? Y squared is y times another, y times y times another, y times y. So all told, how many y's do we have being multiplied
6.
together? We have 6 of them. Okay? 10 cubed, x cubed, y to the 6th. 10 cubed, x cubed, y to the 6th. That last one, not only do we have parentheses, but we have a fraction too. How fantastic, right? So when we write this out in expanded form, the base of this 2 is this entire thing. The entire thing is being squared, which means that we have 5n squared over 4, didn't write that 4 very well, 4t cubed times another 5n squared over 4t cubed, right? Whatever those parentheses contain is the base of the power, no matter how big the expression, how complicated a fraction or whatever. What parentheses do with the power is say, no, this is what's being squared. Something times itself. This entire fraction times itself, right? How many 5s do we have being multiplied together?
2.
How do we write that?
5 squared.
5 squared. How many n's do we have being multiplied together?
4.
4. Why is it 4?
Because there's 2.
Because each n squared represents 2 of them, right? So n to the 4th. Our denominator. How many 4s do we have all being multiplied together?
2.
2. How do we write that?
4 squared.
4 squared. How many t's do we have all being multiplied together? 6 of them. And why is it 6? Because each one of these represents 3. A t cubed represents t times t times t, right? And if we have 2 t cubes total, we have t to the 6th. Okay? So using expanded form, we can eliminate parentheses from an expression by writing it out and combining everything that we have, all those like terms, so to speak, that we have there. Okay. Now, like we've done in the past, we're going to skip the rule here. We're going to cover that tomorrow. Okay. And we're going to go straight to some more examples so we can see how this works. For your homework, you will need to write this out in expanded form. Basically exactly what we did here. Okay. And then tomorrow, we're going to get into the shortcut. Even though I kind of gave away the shortcut earlier, but you probably all forgot that by now. So, Nolan.
So you have to show your work.
You do need to show your work. And by show your work, in this case, it means write it out in expanded form, right? Anyone still need the notes here? Okay, all right. So moving down to some examples here. 3n cubed, very similar to 3n squared. But what is being cubed?
Oh, the 3n.
The 3n. So we have 3n times another 3n times another 3n. How many 3's do we have in all? 3. How do we write that?
3 cubed.
3 cubed, right? 3 to the 3rd power. Oh, good. Okay. And then how many n's do we have total? being multiplied together?
Three.
3. How do you write that?
N cubed.
N cubed. Good job, Nolan. I'll give you a Darth Vader for that one. Excellent. Okay. So 3 cubed N cubed is our simplified answer here. Where that comes from is that if we're cubing this entire thing, 3n means it's a 3n times itself, like we have written up here. How many 3's do we have all being multiplied together? 3 of them. 3 cubed. How many n's do we have all being multiplied together? 3 of them. That's where the n cubed comes from there. Okay. The next one. 2x squared y cubed, all that to the 4th power. That means this entire thing is the base. We are taking 2x squared y cubed and multiplying by itself 4 times. So 2x squared y cubed times another 2x squared. Well, I gotta write smaller. I gotta start over again. There we go. Forgot how long this one is. 2x squared y cubed times another 2x squared y cubed times another 2x squared y cubed and times another 2x squared y cubed. Oof. Okay. Now, how many 2's do we have all being multiplied together? Somebody ever heard of me yet today, perhaps? Count up all those 2's. Mia, 4 of them. How do we write that?
4 to the 4th.
Not 4 to the 4th. 2 to the 4th, right? We have a 2, a 2, a 2, a 2. Total, we have 4 of them, which is not 8, right? 2 plus 2 plus 2 plus 2 is 8, but not 2 times 2 times 2 times 2. That we write as 2 to the 4th. How many x's do we have all together here? All being multiplied together. Josie, 8 of them, right? Because each one of these represents 2. 2, 4, 6, 8. That's x to the 8th. And how many y's do we have all being multiplied together here? Landon.
12.
12. William, what are you chomping on over there? What are you chewing on? Your pencil.
Yeah.
Fantastic news for your health and safety.
Wait, what?
So 2 to the 4th, x to the 8th, y to the 12th would be our simplified answer. Okay? 2 times 2 times 2 times 2, 2 to the 4th. We have 4 x squared terms, total that's 8. And then y cubed, total 4 of them, that's y to the 12th. Okay? I'm going to get you started on a couple of these just because they throw in some other rules a little bit. That bottom one there, 15x to the negative second squared, I'd recommend, and I advise you up here, it says, may I advise you to simplify what you can inside the parentheses before you distribute. Because the more complicated your base is, the more complicated the simplifying is. So what can we do inside of our parentheses? We're not going to do anything yet, but just inside our parentheses, how can we simplify 15x to the negative second? Inside the parentheses, how can we simplify 15x to the negative second? Negative power, CO13, what do we do with it? Don't overthink it. What does the negative power mean? It's the wrong part of the fraction, right? So if this is 15x to the negative second, you've done things like this before. Just flip back a page, okay? The 15 is going to stay in the numerator. The x squared goes to the denominator, and the power becomes positive. Now, this looks a lot like that fraction example we had up at the top of the page, right? Where the base is a fraction, meaning what you're squaring is 15 over x squared by 15 over x squared. What does that equal? And you can look back at the example in the top part to kind of guide you there, okay? The second one I'm going to help you with is this one over here. the last one, since I don't even ask for the last one anyway, right? But notice here we have n's in both the numerator and the denominator. N's in both the numerator and the denominator, which means we can simplify. Whenever you have more than one of the same base, you can always combine them one way or another. So what I'm going to do is I'm going to start by moving my n to the negative third down. Because again, it's a negative power. It's in the wrong spot. So since it's in the numerator, I'm going to move it down. The coefficient 3 stays right where it's at. And my denominator now becomes my coefficient of 2 times n squared times n to the positive third. Right? Because when I move that n to the negative third down, that power becomes positive. That's why we move it. How many n's do I have in my denominator now? Lennon, total of 5. So I can simplify this a little bit. And rather than 3 over 2n squared n cubed, it can just be 3 over 2n to the 5th, and all of that being squared. Now, it looks exactly, well, not exactly, but you know what I mean, very similar to the one that we just kind of went a little bit further with there. So like we've done in the past, your homework for tomorrow is going to be to finish this section, writing it out in expanded form, showing your work. You've got 4 left to do. 2 of them are partially done for you there. Then tomorrow, we're going to talk about the rule, and your homework over the weekend, homework for Monday, is going to be the second page of this. Okay? Then we'll cover PO15 on Monday and Tuesday, review Wednesday, test Thursday, Friday. That'll be the schedule for next week. Okay? Questions? Comments, concerns, complaints, compliments, congratulations, criticisms, and
I have a question.
yeah.
On the last one, when you're like moving n to the negative 3 down
Yep.
to the original number, would like subtracted instead of added?
So once you move it down, it becomes positive. So then you'd add the powers 2 plus 3 there. If you subtracted them, the exponents, like if we had n cubed, n to the negative third over n squared like this, and you wanted to subtract them, what's negative 3 minus 2?
5.
Negative 5. Uh-oh, we have n to the negative 5th in the numerator, which means where we got to move it and make it positive. There it is,
Oh,
right? So you can do it that way too, as long as you know what you're doing. The nice thing about these rules is they all connect, right? They're all intertwined with each other. Also, don't forget today is Thursday, which means Khan Academy is due tonight. So if you've been putting that off for a while, then get it done before 11:59 p.m. tonight. Mia,
Second row, the first one. Oh, what's the x?
this one?
Yeah.
Doesn't matter what the x is, right? You're just combining x squared times x squared. The same thing that we combined, n times n here. We didn't care what n was, what the number was. We just combined how many n's we had. We had n cubed. Okay? So you're not solving here. You're just combining. Anything else? Okay. That is how you math. Thank you.